Notch has an incredibly powerful particle system, and in fact, this is one of our most popular features. In this chapter, we'll learn how to emit, control, and render them. We'll look at creating particle systems using image, video, and 3D space. We continue with our workshops in this chapter, so please follow along and learn as you go. Hello and welcome back to the Notch Essential course. In this chapter, we will talk about particles. But before we start, let's make sure that our assets are actually ready for us to work with. I see that these two videos needs relinking, so I'm going to go for Find Missing Resources property, and I'm going to find them in my Windows file structure. Okay, I think now we're good to go. We're going to start with the first layer, the blank, and we're going to talk about a basic particle setup. So the basic particle setup consists of 4 nodes. First of all, we need a root, and as you notice, there's quite a few of them to choose from. So in this case, we're going to go for particle root. We're going to connect that to the root of the scene. Now, particle root will be responsible for basic rendering properties of particles. So basically here we can set particle allowance, pre-roll, and emission settings. Think of it as a hub for everything else to come when it comes to particles. Since particles is quite a big subject here in Notch, everything related to particles will be color-coded orange and will be connected to this particle root. So the next step would be to add some kind of an emitter. And again, if I type in emitter, I'll see that there's quite a few to choose from. The one we want now is a primitive emitter and a renderer. So out of all the selections we have here, I'm going to go for point renderer. If I hit space, I see my particles already spawning and working. Let's focus on these 2 nodes and let's talk about their properties and variables. So primitive emitter, or actually any emitter, is responsible of defining how does the particle emission shape looks like. In this case, it's a sphere. We could actually change it to a box, and if I hit space again, I see that all of a sudden our particle system becomes a box. We have quite a few other options here too, but I think I'm going to stick with a sphere with the default. By the way, if you want to reset your playhead, all you have to do is press home, or if you're using a laptop, that would be Fn and arrow key back. You can actually do that in Notch UI as well. Just press this first button right here. Right, so not only it sets the emitter type, it actually sets the particle life as well. So default is 5 seconds. We're going to come back to that and change as we progress. And here we can set particle count as well. So the default state is 30,000. And now I'm going to draw your attention to the fact that there's particle number or num-particles here in the particle root as well. So why do we have 2 places where we count particles? Well, in a primitive emitter, or any emitter for that matter, you set a specific particle number that you want to use. For instance, 29,999 particles. And in a particle root, you set an approximate number of particles that you anticipate you will be using, and then a Notch system allocates required compute power to actually make that happen. So again, this is where you set a particle allowance, or the compute power, and this is where you set specific numbers of particles you want to see on the screen. These 2 settings will start to make more sense as we progress, and we're going to talk a little bit about optimizing particle systems. Right, so with that said, I left my number of particles here at 64,000, which is the default, and I'm going to bring this max particle count to a default too. So I'm just going to use this button, reset property to default. Great, so now we know a little bit more about particle root and a primitive emitter. Let's talk a bit about point renderer. So if I zoom in a little bit closer, I see that all my particles are little quads. We can change a texture or a shape of this particle by bringing in some sprites to our resources, or by building some of our own. We can use any and all generators to build sprites. For instance, I can grab a star generator and connect it to the first input of the point renderer. All of a sudden, all of these particles are in a sprite of a star. But I think the better choice would be to build a round particle. So let's go for gradient. Let's connect it to the very same input. I see it's working. Great. I'm going to press on the preview in the viewport so we can actually see it better and shape it. Instead of mode linear, I want this to be mode radial, and I want to increase the inner range. There we go. Now we have a circle. Perhaps I should make it a little bit smaller. So 0.9 all three properties here, scale X, Y, Z. Right, and there we go. Now we have a circular sprite. That's great. Again, you can bring in your own. I would suggest using something like PNG or DDS files, but generally, in most of the cases, you probably will be able to build a sprite out of the generator. Right, so let's talk about a couple of more properties in Point Renderer. In this case, it's set to a blend mode linear. We can always set it to additive or any other, but I think I'm going to stick around with the default linear. Important setting here would be size randomness. As I increase size randomness, all of a sudden this setting looks a little bit more dynamic, but there's a little gotcha. Notice what happens if I increase the size randomness above the numeric value of 1. All of a sudden we see less particles on the screen. So the smallest particles are so small that they're not even rendered on the screen. But we are still taxed by a system for the number of particles that we have set here in a primitive emitter. We definitely do not see 30,000 particles here, but we do pay a price of 30,000 particles. So very big advice here is to never exceed a setting of 0.9, for instance. As soon as you go above 1, you actually pay for particles that you do not see on the screen. So please always keep this under 1 or under 0.9. Right, so we do have particles. They are spawning in a sphere. They have a circular sprite, but they have no motion or no animation of their own at all. Let's address that. Let's add one more node, the fourth necessary node, and here we can choose from quite a few. Let's add an effector. So effector defines how particles animate and what do they exactly do. I think I'm going to start with turbulence. So I'm going to connect it to the particle root, and as soon as I do that, I see that my particles became alive. It's great. I think I'm going to increase the velocity amount because I want them to spread out a little bit further and a little bit faster. So this is already somewhat more exciting, but I think we could push the setting a little bit further by adding some shading to it. I propose we use Live Color Shader. Now, Live Color Shader consists of a gradient of 4 colors, and these 4 colors appear on the particle system throughout the span of particles' lives, so from the birth to death. Let's set some kind of a gradient. Yeah, something like that. Or like this. There we go. So all of a sudden, we have shaded particles that has behavior and that has a circular sprite. Now, we're not bound to use just one effector and one renderer per particle system. We can actually use quite a few, and if you check the list, we have options. We have quite a few effectors. And if we go to rendering, we have quite a few renderers as well. So with that said, I think I'm going to grab Geometry Connection Renderer and I'm going to connect it to the particle root. As soon as I do that, I see that my particle system already all of a sudden has a little triangles. That's great, but that's not necessarily the thing that I wanted to happen. So I'm going to go for Geometry Connection Renderer, and I'm going to tick off Draw Triangles, but I'm going to expand the lines bracket, and I'm going to enable the lines. Perhaps lines could be a little bit less intrusive, so I'm going to decrease the alpha. 0.3 seems to be a good setting. And I'm going to tick on Use Vertex Colors, because I do want this to follow the colors that are given by Live Color Shader. Okay, great, but I think our point renderer is a little bit hard to read. So in a point renderer, I think I'm going to add a little bit more on the particle size, maybe 3. Ooh, that's a lot. 2 probably is much better. One more setting that I haven't mentioned in the point renderer, which comes quite handy, is motion blur. We can always add a little bit of motion blur. There we go. Well, let's be more generous. Let's add 2. All of a sudden, this looks a little bit more dynamic. Great, so let's add an extra type of behavior. How about curl noise? Now, in essence, it's very similar to turbulence effector, but let's just add it in. Curl noise fluid effector. I think I'm going to decrease the fluid simulation speed to 0.2. I'm gonna give a lot of curl though, so I want a big noise here, so maybe 150. Oh, it's definitely working. It's not looking pretty, but it is working. I think the noise size could be smaller, so I'm gonna set 0.2 there. Ah, now we're talking. This is looking a little bit better, a little bit more interesting. Right, so now we used 2 renderers and 2 effectors. Although we do have only one primitive emitter, we actually can have several emitters. I'm just gonna grab a new one. So I'm typing primitive. There it is, a primitive emitter. I'm gonna pull it a little bit on the side. And I'm gonna hit space to render. So now we have 2, but they behave and look exactly the same. Let's space them out a little bit more so we see them better. Well, we can address how they look and how they behave separately. We're not obliged to connect all the particle-related things just to the particle root. We can actually connect them to the emitters as well. And I'm going to explain you why would you want to connect specific renderers and specific effectors to specific emitters in a second. Let's just split the looks and behaviors first. I think I'm going to give geometry connection renderer to this first one. There we go. And I think I'm going to give the point renderer to the second one. So one of the emitters now is expressed with the lines and the other one is expressed with dots. All of a sudden they start to look a little bit different. Actually, if we grab the live color shader and add it to one, copy it out and add it then to the second one, but add another type of gradient, they will start to look reasonably different. So now they do look different, but they still behave quite the same. So I'm going to split the effectors too. So turbulence will go to the first primitive emitter and the curl noise will go to the second one. So I mentioned that I'm going to explain why is it handy sometimes to connect specific effectors and renderers to emitters. Well, I think I can showcase that. I'm going to grab the curl noise fluid effector. I'm going to make the radius of it quite small. Let's say 2. That's small enough. Or actually, that's too small. Maybe something like 3.5. Yeah, that's going to work. So notice its position when it's connected to the primitive emitter. And now notice how the position changes when I connect it to the particle root. All of a sudden it jumped to the center. So I'm going to press Alt-G so we see the grid. And now it jumped to the space or the location of the primitive emitter. So all of a sudden, if you connect a specific effector to an emitter, emitter's location becomes effector's center position too. So if you're working with something like interactive settings where you have tracking happening like black tracks or motion capture suit or something of that matter, or even if you're using something like Windows Touch, you probably want to connect everything to the primitive emitter. So as you are moving the emitter, if you expose that parameter to be controlled by another system, all the effectors follows through and has the same type of motion. Anything connected specifically to the emitter inherits emitter's location and rotation. Right, I think now I'm going to make this a little bit more readable. I think it's hard to understand what's going on when all the lines are intersecting and overlapping. Okay, let's talk about useful tips. In this case, we have 2 emitters. Both of them are drawing 30,000 particles. That's great. In the particle root, we have allowance of 64. So there's plenty to go around, but look what happens if I reduce the particle numbers here in the root. All of a sudden, one of the particle systems has just less to go about. This one is fully 30,000 and this one has only a couple of thousand to go about. When you're building your systems and if you're using several emitters, or if you bump the emitter numbers of the particle, or if you bump the particle numbers in a specific emitter to a bigger number than a default given in the particle root, always make sure to flush those numbers out. So if it's 30,000 here, 30,000 here, I definitely need 64,000 to go to have an equal amount of particles on both. Again, this is where we set the allowance. Compute power, this is where we set the exact number of particles we want to use. So, handy tips and tricks. If you want to use some kind of a post effect here, very likely you already have your eyes on glow because particle systems has to glow. That's a law. You add the glow and it's all working, it's all fine, and all of a sudden you add something like Shape 3D, and the Shape 3D is actually glowing as well. But what if you want to make sure that the Shape 3D is not affected by the glow and it's only particles that are glowing? Well, then you have to split the rendering paths. You can do that with render layer node. So anything connected via render layer has a separate rendering path. Let me showcase that. So I'm going to disconnect the glow now, and I'm going to disconnect the particle system from the root. I'm going to connect the render layer, and from render layer I'm going to connect particle root. There we go. Now I can connect the glow to the render layer as well, and all of a sudden it's only particles that has this glow effect, because all of a sudden we split the render paths. There is no limit on how many render layers you can use, but just be aware that render layers introduces a little bit more compute to your GPU. So I would suggest to keep the numbers of render layers modest. Otherwise, you will see a significant decrease in your performance. Another thing that I want to mention about render layer is the fact that it has different blend modes. In this case, I'm not necessarily happy with this blend mode, which is blend with alpha channel. I think I want something else. I think blend with luminance as alpha works for me much better here. So just be aware, you can actually pick and choose any and all available blend mode here. I'm going to mention another handy tip. For instance, you build your particle system, it's looking quite nice, your customer is rather happy, but then at some point your art director or that very customer comes back and says, this is great, can it be 5 times slower? And then you're stressed out thinking, oh God, I will have to slow down every single effector, it will change the way the systems behave, this is not going to work out. Well, fear not, our development actually took care of us here. We have a node called time stretch. So if I connect anything via time stretch, and if it's a generative thing, build a notch, all of a sudden I have an overall control of time. So if your customer says, I want this slower, no problem whatsoever. You can slow it down using time stretch. Right, so I think I'm going to leave you guys to explore further the different effectors and different renderers, as there's plenty to choose from. And I think you should be familiar with quite a few of them, to be honest. There is no shortcut in learning what do they do and how do they behave. It's literally all about dragging it in, connecting it to the particle root or a primitive emitter of your choice, and seeing what it does and seeing how you can tweak it out to your liking. All right, see you in the next workshop. Welcome back to the particle chapter. Since we're done with the basics, I think we can move on to something a little bit more exciting. So I'm going to draw our attention to the third layer, geometry-based particle systems. So this is more or less what we are going to build next. And trust me, it doesn't require that great many nodes to achieve this look. Right, let's get started. I'm going to make a new layer and I'm going to call this geometry particles. So the starting point here will be just the same as in the previous workshop. We will need a particle root. And we're going to need some kind of an emitter. So in this case, we're going to go for the very same primitive emitter. We will need a renderer, but instead of point renderer or geometry connection renderer as we've used previously, we're going to go for trail renderer. There we go. Now, mind you, don't grab the trail emitter, grab the trail renderer. They're quite similar, but they fulfill very different tasks. Cool, we have 3 main nodes in the scene. Let's start animating. Well, look at that. I started playback, but nothing is happening. Well, there's a good reason why nothing is happening. Trail renderer does not draw trails unless it actually sees some kind of a motion path. So motion path would be given by any and all of the effectors. So for this setup to actually run, we need some kind of an effector. I think the first one we're going to add here will be curl noise fluid effector. There we go. As soon as we add that, we see the trails. Great. Let's make some changes to the curl noise fluid effector. I think we don't need that much of speed here, so maybe 0.17 on speed value. I think it would be nice to have quite a bit of curl, so let's just put some insane number like 300. It is working. It looks horrid though. Let's fix that. I think if we drop now the noise size to something reasonably small, this will start to look quite nicer. There we go. This is much, much better. In fact, I think we can add one more effector to make this a little bit more exciting. How about turbulence? We are all familiar with both of them now. So turbulence effector, I'm going to connect it to the particle root. And let's change some values here as well. I think velocity could be bigger, so maybe 13.5. Radius, however, could be smaller, so maybe 4. Yeah, I think I'm going to leave it at that. To be honest, I think we have too great many particles in this scene. Since we're going to be translating this all to geometry, first thing we should do, we should make sure that we are using less particles. In the primitive emitter, we have a max particle count property. I'm going to drop that down to something like 8,000. I'm hitting home to reset the playhead. Yep, that looks a little bit more reasonable, a little bit more down to earth. Okay, so we do have some behavior. We have a renderer and we have an emitter. In fact, in emitter, we could expand the particle life to 8 seconds instead, so that they just decay for a bit longer. They stay on the screen. They stay with us on the screen a little bit longer. Great. So how do we translate all of this to the actual geometry? Well, in a trail renderer, we have a property called primitive type. So default is thick lines. Let's change it to extruded geometry. As soon as we change it to extruded geometry, we actually have a 3D object available here. So all of these lines all of a sudden are in 3D. Great. Although there's one problem. I think it's very hard to read what's going on because it's so super flat lit. I think we need to make some changes here. We need to add some lighting. I'm going to go for skylight. Now, before I connect it to the root, I have to make sure about a couple of things. First of all, it's going to be very expensive on my GPU, so I'm going to reduce the num sample directions to something more appropriate, 50, or actually 20. Now I can connect it to the root. I did connect it to the root, but it's still hashed out red. There's a good reason why it's hashed out red, because in the root node, I definitely have to enable deferred rendering so that a computer would know, so that Notch would know that it has to up its game and do some extra computations. I'm gonna enable the high dynamic range too, and I'm gonna preview how things looks now. Well, I think this is a little bit more exciting. This is way better. Back in the skylight, we might as well tick on omnidirectional, just so the light distributes a little bit more nice. What we should do in trail render, I think we should make these lines thicker. So the line thickness, I'm going to set it to 2. Actually, I'm going to be generous. I'm going to set it to 3. And I will reduce the particle life. I don't think having it living for 8 seconds is a good idea. Let's drop it down to 4 seconds instead. I think this definitely works. So back to trail render. Can we get away with 4 on that line thickness? I think we can. Okay, cool. So this is quite nice. Maybe let's expand a little bit on lighting. So we have a skylight. So why don't we add an environment map here and take advantage of that? I'm going to go to my assets, HDR folder, and I'm going to choose one of the HDRs available. Perhaps glass passage would work for us here. Cool. So now we have a HDRI image. We can use that with the environment map node. So I'm going to connect that to the root. I'm going to connect the video loader, this HDRI image, to the environment map, and I'm going to feed this environment map to the skylight. all of a sudden these two are working together. Great. Now, I don't really think that I'm having the best performance available. I kind of feel that my machine is underperforming, even though I have quite significantly powerful GPU installed in it. I have 2080 Ti. There's a good reason why it's a little bit underperforming. So by default, I have my frame rate locked up in this file. So if I press on the P icon here, you will see that my minimum and maximum is set to 25. So the default state would be 0 and 999 on max. So let's see the actual performance. 27, 26, 25. This is not great. It's not a big, 12, 24. This is not great. There's not great many particles here, but the performance is rather poor. You remember I mentioned that it's quite important to keep track of number of particles as an allowance and number of particles as an actual use. So if we're only drawing 8,000 particles on the screen, there is no need to ask for Notch to allocate 64,000 from the system. As soon as I flash these numbers up and restart the playhead, I see that my performance jumped significantly up. I'd say almost 2 or 3 times better performance right here. Cool. Although the particles now looks quite different, the trails are quite shorter. There's a reason why the trails are shorter now. Since we have a variable frame count, there's a variable in the length of the trails. That's why we had this setting, the time property, locked to 25 by 25 by default. So check this out. If I'm going to lock this back to 25 by 25, all my trails are significantly longer. That is because now every single trail knows that it has to be counted as 25 FPS item. Cool. I still want this a little bit thicker, to be honest. Maybe 6. Oh yes, now we're talking. Now it's much better. Maybe the primitive emitter, or actually, yeah, maybe primitive emitter could be smaller too. Let's go and make it 0.5 on all 3 axes. I don't think this actually made it better. I'm going to bring it back to 1 by 1 by 1. So we do have a little bit of lighting here. How do we expand on this setting? Obviously, we have only 5 nodes to make this particle system run and a couple of nodes to make a lighting system run. I think we can just build on it. I think we can just make it a little bit nicer and more interesting. I think I'm going to reduce the brightness of skylight. And I'm going to add some regular light. So light, let's connect it to the root. I see it come into the center of the graph. I definitely want this to drop a little bit of a shadow. Oof, what a harsh shadow it is. I'm just going to make sure that it's a bit softer. Let's add some drama. Let's put this downwards. Let's give it a color, maybe a bit warmer color. Let's make a copy of this light. Connect it to the root. Let's bring it to the other side. So up and around. And let's rotate that. Let's pivot it downwards. Maybe a bit higher up. This will be a cold light. Okay, now we have a little bit more drama going on in this shot. That's good. What else can we do to make this visually appealing and interesting? I think we can come back to the trail renderer and change some settings here. Perhaps we should go for length, and length should be just 1. Let's see how that looks. I actually like this a little bit better, especially if I was to come back to the live setting and yet again expand it a little bit. How would that look? We're talking particles. This is literally changing a setting and seeing how it behaves and changing a setting again and again and again and again. That's pretty much the whole workflow. You just tweak things, and lucky for us, you actually see them on the screen live. Let's use time stretch. Let's slow things down. Let's mellow things down a little bit. So time stretch to particles. Let's drop the time a little bit. Let's restart the playhead. Ah, look at that. This is much better now. This is much, much more interesting now. It's in the primitive emitter. We have 6 seconds of live. What if we had it shorter then? Yeah, 2 seconds actually works. So this is the sweet spot. Cool. let's do a couple more things. I think it would be nice to have a camera here. As I'm connecting camera to the root of the scene, I see that it came into the center of the graph. Just gonna pivot it backwards a little bit. Or actually, I'm gonna use this property called camera options set to current view. So I'm just gonna find the position that I like. Perhaps this, and I'm gonna click on camera options set to current view. And if I hit 0 now, I'm looking through this camera to the particles I've just built. Okay, cool. Oh, they are a bit thick now. Why don't we set this to 4 instead? There we go. I would like this camera to turn around and around this setting. So just like in a modifier chapter we build a gimbal, I think we will do that same thing here. So let's grab a null. Let's reconnect camera through the null. And now we can turn around this setting with a continuous modifier. So I'm gonna grab continuous modifier and I'm gonna connect it to the rotation heading property. It's rather slow. Let's bump up the numbers. 20. Great. Let's do some housekeeping. Let's put all the lighting nodes here on the side. And let's leave some space for camera here in the bottom. What else can we do? Let's grab a light scattering beam. We haven't tried this node yet. It's a very nice little node that helps us to build a little bit more dynamic background, because in this case now it's just black. I don't necessarily like it just black. So it comes in as a sphere of light. I'm just going to decrease the brightness a bit, but it doesn't respect the actual geometry in the scene. So we can enable the depth test. And as we do that, it will start to respect the geometry that is in front of it. Or actually, let's just keep it in the center. But let's make it blue and a little bit darker. There we go. I think this right here starts to look like something. Now, as previously discussed, we can use several renderers. So why don't we bring back the same geometry connection renderer? I do like the lines. I don't necessarily like the triangles. Obviously, you can keep it if that's your choice. My preference is to tick off the draw triangles and bring back the lines. There we go. Those lines are a bit thick. I'm going to reduce the alpha and it's not going to be that thick anymore. I want these trails to have some kind of a color. In this case, instead of using a live color shader, I think I'm going to go for color ramp. And I'm just going to connect this color ramp to the primitive emitter's color control node. So now these two nodes can work together and control the color. So maybe one should be, say, orange, and the other one could be, well, maybe magenta. There we go. In a primitive emitter, we have a whole bracket for the color control. So we could choose it. We could choose to go for input control, for input color, or emission time. I think I'm going to go for emission time. How would it look with a random color? Yeah, let's keep it the random color. So now if I come back to the geometry connection renderer, I can tick on use vertex colors. And since we colored the emitter, we actually can tick that on and it will work. Now we're using vertex colors. Maybe we should add a point renderer to this setting. Connecting it to the root. It came in as a little quad right there. I see it already. Let's make the particles a little bit bigger. Now, it is drawing these quads on every single available particle, on all 1000. I don't necessarily want that. I think I'm gonna go for the setting called use particle. There it is, particle use amount. Let's drop that down quite a lot, maybe 0.1. So it's only on, well, probably 1000 or so. I think we could make do with even less. There we go. Let's make these quads into circles. So let's grab gradient. We already know what to do with the gradient, so we're just gonna pipe it into the first input. We're gonna make it radial, and we're gonna increase the inner range. Okay, there we go. Could those particles be bigger still? Absolutely. Could they be in size random? Yes, sure. Should it exceed 1? Absolutely not. As we discussed, that would just kill off the smallest particles on the screen, and we would be taxed with the things that we don't render. Should we change blend mode? No, I guess linear is fine, but we should add some motion blur. Maybe more motion blur. It's a little bit hard to read motion blur when everything is so slow. So maybe 5. Yeah, there we go. This is a little bit more interesting. So these geometry connection trails, could they be a little bit thicker then? I don't think that lines alpha setting is actually making a big change for me now. I think I'm going to tick on thick lines. And now I have a setting that I can use, so thick line width. So let's just make it a little bit thicker. Not too much, just a little bit. So why don't we bring this asset that we used before, the 0.6 ring, and why don't we just attach it to the camera so we encapsulate this setting so it looks a little bit more wrapped or bounded. We will need a image plane. Now we have to send that image plane a little bit backwards or forwards on the z-axis because now it's literally living exactly where the camera is. So let's just pull it back. Now we see it on the screen. Let's feed this video loader to it. It could be probably closer to us actually. There we go. Maybe a bit bigger. And it's very intrusive, so maybe the alpha could be a little bit reduced. Could we change the color? We could, but do we have to? Absolutely not. I think this works as is. Okay, cool. So how about some post effects? Mandatory glow. Oh, it's a bit harsh. So let's increase the threshold, maybe reduce the softness. Let's take out the blur scale. Intensity? Nah, we don't want much of it. Let's just keep it to a modest 0.2 setting. Yeah, it added a little bit extra touch, just a little bit extra glow. That's exactly what we were aiming for. Cool. Colors, could those be nicer? Could those be something more exciting? If it was yellow and red, would that be nicer? Would that work? Actually, if there were 3 of them, maybe that could be a little bit more fun. I know, it's our environment map, and it gives a very specific shade of blues. So if now I come back to my available assets, HDRIs, and I just bring them all in, because why not? I'm gonna cycle through and choose some other one that hopefully will fit this better. Yeah, I think this looks nicer. And in fact, I can even bring some colorlets, because I do have some of them available in assets. Well, I can grab any from the available list, connect it to, say, camera, and just cycle through and find the one that works best for me here. I think I'm going to stick with Brandon. Maybe it shouldn't be so powerful, maybe just 0.5 on that setting. But yeah, we're getting there. Okay, I think you're getting the gist of what I'm doing here. I'm fairly sophisticated to leave you guys to it, and I'm sure you're going to build something really cool, really fun looking once you're done with this workshop. In the meantime, I'm going to prepare for the next one, so see you there when you're ready. Welcome back to the particle chapter of this essential course. Now, the next upcoming workshop we're going to be tackling is all about image emitter and how do we grab a video and translate it to particles. So let's get started. Let's build a new layer. Let's call it image emitter. Great. So starting point here will be just the same. We will definitely need a particle root. But instead of using a primitive emitter, we will use image emitter. Now notice that field system and particle system have image emitters. It's very important to follow the correct color codes. In this case, we're going for the orange one. It came in hashed out red. That's all fine. That's exactly how it should be. So we're going to connect it to the root now. We're going to add one more node before we go for video processing, and that's point renderer, as we definitely need some kind of a renderer just to see what's going on and how do the particles look. Right, so our particle setup, initial setup, is actually complete. Let's talk a little bit more about image emitter and why is it hashed out red. Well, as you see, the first input here is marked up gold, and it's stating that it's required. And that required input or extra node in this case is video. So I'm going to grab this base video. We are all familiar with it now. We worked with it in the video processing chapter 2. So I'm going to plug it up straight to the first input. There we are. We are rendering a video to a particle setup. Although these particles are not necessarily following the video, so I think that's exactly what we should address next. So in order for particles to follow the motion of the video, we need two extra nodes. So we need downsampling, so downsample node, and optical flow. Now, we could connect video loader straight to the optical flow, and optical flow would fulfill its task, but optical flow as a tool doesn't require HD signal, so we can easily downsample it before we send it to optical flow. So let's just do that. From the video loader, I'm going to connect it to the downsampling. By default is set to iteration 1, and all of a sudden I see that I have a hint that now my video is 960 on 540 resolution. We can actually preview as we change the resolution. If we set it to 2 iterations, this video now is 480 on 270. So as we increase it, it just drops the resolution accordingly. I think we're going to stick with 2 iterations. So that will be 480 on 270. That's just great for us. Now we are ready to connect it to the optical flow. Now, optical flow is not necessarily a looker. It's a technical tool that allows us to calculate motion vectors. I'm going to go ahead and connect it to the second input, motion video node. That's exactly where it belongs. And check this out. All of a sudden, it is actually working. Great. So there's a couple of more things we have to do to make this look a little bit better. For instance, first of all, this is a square. This is a quad. Our actual video is a 16 by 9er. So let's fix that. On a scale X, we can use a small little formula, 16 divided by 9. And a notch will calculate the correct scale X for us in accordance to the rest of the image. There we go. This is much better. Another thing that we should address is the pixel cull thickness mode. We don't have any alpha in this, so let's just go for luminance instead. So I'm restarting the playhead now. Yep, a little bit better. And we have alpha threshold property. So alpha threshold just kills the darkest particles. I think we could easily set it to 0.2. Because as we are moving about, there is this shot right here on the side. So it's literally just a gray wall behind the musician, and we just don't want to see that at all. So that's why I increased the alpha threshold. I think it's still a little bit hard to read what's going on, so I'm going to increase the particle numbers here. My particle allowance is 64,000, and the image emitter is drawing only 30,000. So I'm going to match up the numbers. I'm going to set it to 64,000. Yeah, the image became a little bit richer. Actually, we could probably bump up the threshold a little bit more because we still have these gray particles there. How about 0.3? Yeah, we definitely have less of them there. That's great. Okay, so system-wise, this is actually working. We probably can tweak out the settings a little bit more later, but now we should address the point renderer. it doesn't really look nice with those squares here, does it? So let's grab a gradient and let's build a circular sprite. So I'm setting it to radial, or in fact, let's change things up. I'm gonna delete this gradient, and I know that I have a circle.dds sprite available for me in resources. Now, I got this sprite from documents, Notch sample project, sample resources. So these are a couple of handy little assets that you might find useful in your day-to-day Notch use. Cool. I think I'm going to introduce a little bit of size randomness, so 0.9 there. Great. One issue though, we have quite a few particles sticking on the edges of this setting. That's not necessarily good. We're just rendering particles for no reason, basically. So we can fix that with an extra effector, and that extra effector is Killbox. So Killbox effector, I'm going to connect it to the root. See, it's working. I'm going to apply the same formula so that this would become 16 by 9 as well. And look at that. It does exactly the opposite of what we needed to do. So we can just change the kill operation from, kill mode from inside to outside, and yep, that pretty much fixes it. Looks much better now. Another thing that I would like to address is the fact that we're in 3D space, but we are looking into a 2D image. So I think having camera, I'm hitting 0 now, would actually help here. So I'm just gonna pan out till I fill the whole screen, and I'll just keep this camera straight forward. So we just make sure that this is filling the whole available canvas. There we go. All right, so this is the basic setting. This is the basic core setup. We can just push it a little bit further and make it nicer. I'd say maybe we add a bit more of renderers. Our best friend geometry connection renderer. How would that look here? Not great, not fantastic, I'd say. Again, the triangles, I'm just not a big fan of these triangles. I'm gonna take that off, but I'm gonna definitely enable lines, click on use vertex colors, and I'm gonna make these lines a little bit less visible with the lines alpha property, 0.3 for instance. In fact, there's a particle use amount. We could drop that, so we could just use less particles, for instance. That could be nice. I think this is actually nice. I think it works. This setting right here still lacks readability. Now, we all know perfectly well how this basis looks, but your customer or your talent might come back to you and say like, yes, this is beautiful, but I just cannot see myself here. Can you make something so that I could be easier for people to see my face and my base and so on and so forth? Well, actually, we can do that. We can add readability by perhaps introducing some edge detect, so we just see the outlines. So for that, we would use an image plane. And we would have to decide, should we render this image plane in front of the particle setting or behind? Stacking order still applies. It's just the same prominent thing as in a video processing chapter or any other. So I'm gonna put it in the back. I actually want this in the back. Now we could connect the video loader straight to the image plane, but if we want to add this edge detect, we would then have to add it either on the whole scene via root or the whole processing chain via video loader. So instead of that, I want to establish a separate line. So I'm going to put a video null, and I'm going to add that edge detect on the video null. So I'm adding a video null. There we go. And I'm gonna add edge detect exactly on that video null. There is a little issue here. I see that my plane, it's still a quad. So if I unhook it, you will see as well that it's still a quad. There's two ways to fix it. We can set the same formula, 16 divided by 9 on the scale X, or we can use aspect-based scaling mode set to scale X. Now, I would say that perhaps in this case, we should just set a formula manually, so 16 divided by 9. Now, why would I choose to set formula instead of this property right here? Well, if I was to use that property, let me showcase you that. It would actually respect the 16:9 nature of the video, but the first frame would still stick around being a square. Hence, Notch has to take in a frame to account to know exactly how wide or how big should it be. So if you were to render this to video or start playback in another system, the first frame would be a square. That might be an issue for you. So I would suggest, instead of using this property here, let's just set in this 16/9 property. Cool, so this is better. Can we shape our edge detect? Can this be a little bit wider? Should we go for some other mode, perhaps? How about canny? Looks funky enough. I think I'm gonna leave it. What else can we do here? Well, you remember we've spoken about matte workflow. So we could add another image plane here in the front and use fractal noise to reveal parts of the setting. In fact, I'm just gonna build that. So I'm making a copy of the image plane because I'm intending to use the very same settings there. I think I will need yet again a video null. So I'm just gonna pipe it through. There we are. And now I'm gonna go for fractal noise and I'm gonna pipe it to the second input alpha image. There we go. I already see it's working. It's not necessarily doing exactly what I wanted. So I'm gonna fix it up a little bit. So I want this in 1920 by 1080. And I think I want, let's see. I want a little bit more gain here. Actually, 2 is the right setting. These elements are a bit too small, so they could be bigger blobs, maybe something like this, 0.3. Let's preview. There we go. So now we see a bit of a particles there in the back, and we do see a clean image here in the front. That's great. I think I'm gonna change the edge detect from canny back to simple. I'm just too simple. I'm a very simple person. I like simple things. There we go. Maybe some color. Maybe red. Ooh, definitely not red. Blue? Nah, actually let's just keep it neutral. So what else can we do here? Well, we do have all of these LUTs that we brought in for the previous workshop, so we might as well bring those here. So I'm gonna connect it to the root because I want this to apply in an overall setting. I'm gonna cycle through and find one or the other that works best. I think I'm gonna go for the painterly look. Perhaps I can reduce it a little bit, so 0.7. Let's add more effects here. Perhaps we could add frame difference on this front image plane. Let's see how that looks. This could have 25 frames and a different blend mode. Yeah, screen looks quite nice. I know this video null here could be a little bit more contrasted. So color correction there. Let's add more contrast. What if we went for something really outlandish? Recolor. I don't think we used this post effect just yet, and I'm quite keen to show you guys how to use it. So recolor doesn't really do much on its own. It requires a source image. So there's two options. We pipe in the original image, and it does some weird and magical, and it refers to the image itself, or we can actually pipe in a color ramp. And then we will be able to decide what colors do we want to use. Perhaps we're building something like alien setting where everything is visible in infrared. Infragreen, I guess. How does the infrared look? Red and blue. What if we change blend modes on recolor? This was absolutely horrible call. I literally take it back and I'm just going to delete it. But I think it's worthy for you guys to know how to set this one up. Okay, I think this is a very good starting point for you guys to build something nice on your own. Obviously, you can add more renderers, you can add more effectors. In this case, we're just using Killbox, so there's no effectors in many respects. And you can add several image emitters. You would have to pipe in both of those inputs to the secondary image emitter if you want to, I don't know, split the looks, have one emitter with more particles, the other one with less particles. But this is more or less the basis of the workflow. And I'm looking forward to see what cool and interesting things you guys will build.